Okay, here are properties of the standard deviation as a measure of spread. Since we decided to square all of the deviations, S sub x is always positive. In that formula, we subtracted value minus the mean, and then we square them. That makes everything positive. Number two, this should be kind of obvious, but who knows, maybe it's not to you. Larger values of S sub x indicate larger variation or spread. If I have a bigger standard deviation, it's a number that means the data values on average are further away. Smaller values of standard deviation indicate smaller spread. Okay, this should make sense. Let me look at the formula. I'm going to flip this over. I'm going to go back to the... That's not right. I got to go backwards one page. Sorry about that. Now, imagine that you had one more, and it was like $100. It was way up here, and it was $100. Well, you would have 100 minus 7 in here. That's 93. And 93 would get squared. Wouldn't that make this average much bigger? So if you have points that are far away, the standard deviation gets bigger because the average distance away from the mean gets bigger. That's what that means. Okay? And then number 3 here, the standard deviation, like the mean, just like the example you just saw, it's not resistant to the effects of outliers. You put that big old 100 in there and the standard deviation gets much bigger, much quicker. If a data value is a long ways away from the mean, the value of x minus x bar being squared will contribute a big number to the calculation of standard deviation. Number 4, since the standard deviation is calculated using the mean, which is x bar of course, you should only use the standard deviation to describe the spread for a distribution when you use the mean to describe the center. We have a rule about that. If the shape is symmetric, we use the mean. If the shape is skewed, we use the median. So when we pick the mean, we should pick the standard deviation to describe the spread. Of course, I'm talking about socks here, right? Find the shape first. If it's skewed, you should use the median for the center. If it's skewed and use the median for the center, you should use the IQR for the spread, interquartile range. However, if the shape is symmetric, then you should use the mean for the center. And if you should use the mean for the center, then you should use the standard deviation for the spread. Okay, last thing about the standard deviation here. The units for the standard deviation are the same as the units for the mean, which is the same as the units for the data. Okay, so from this SOX conversation, we go, when do I use which one of these things here? Here's the order that it goes. This is pretty important for you. It tells you how to go forward, putting all of this mess together. So I'm going to asterisk it up because it looks important. First thing you should do is determine the shape. And basically, I mean symmetric versus skewed. Take a look at your shape first. Then you choose the measure of center according to the following rule. If the shape is skewed, that means there could be outliers and there's big values to the right or little values to the left, then you should use the median because the median stays closer to the peak. The mean goes towards the tail. If the shape is symmetric though, there's nowhere for the mean to go, so you should use the mean because we prefer to use the mean. And you know what, let's put the variables in there. That's a capital M for median and an X bar for mean. Now 3. To choose the measure of spread from, maybe you guys haven't seen this Don't Forget Your Socks thing. We should talk about shape and center and spread and outliers, and the author likes to use this phrase for you guys to remember that. Don't forget your socks. Every time you describe a distribution, you should talk about shape and center and spread and outliers. So, choose the measure of spread according to the following rule. If you choose the median, then you're going to use the IQR for spread. If you choose the mean, then you're going to use standard deviation for the spread. Basically, I'm saying that the range is stupid. We shouldn't use it ever. Next page.